An AI model just looked at 75 years of trusted chemistry data and basically said, yeah, this is wrong. And the chemist using it did what any normal person would do. Can you believe this? He assumed the AI was broken. Because obviously, right? If a machine disagrees with a reference databases that scientists have trusted for decades, you trust the scientists. Except the machine was right. The published data were wrong. And that is where this story starts, because AI is no longer just helping people write emails, make pictures, or cheat on homework. It is starting to audit science itself. And honey, it is finding things. Now, the title says mainstream science was lying. Let me be precise before somebody starts typing an angry paragraph. A mistake is not automatically fraud. A typo is not a conspiracy. Science is not one evil man in a lab coat twisting his mustache. But when an incorrect number gets published, copied into a trusted database, cited for decades, and used as the foundation for new work, at some point, the system is confidently presenting something false as truth. And you are the person whose experiment fails because of it. That distinction may not feel very comforting. The chemistry example is about boiling points. Sounds boring? It is not. Chemists use those values to identify substances and design real processes, including distillation. That means actual experiments and actual equipment can be planned around these numbers. One bad value does not stay politely trapped inside an old book. It travels. It gets copied. Other people build on it. Then their work inherits the original mistake. The model flagged more than one case. One problem came from a simple typo. Another came from century-old measurements that were just incorrect. These were not random notes hiding in somebody's desk. They had made their way into the scientific record. So yes, an AI catching an old typo is useful. But that is the cute version of this story. The uncomfortable version is, what happened when SAI Labs pointed AI agents at ICML 2026? ICML is one of the biggest machine learning conferences in the world. And these were not rejected papers or forgotten workshop drafts. SAI examined 168 papers selected for oral presentation, the top slice of an already selective conference. Their system did more than skim the PDFs and complain about grammar. It reviewed the papers, code, and data. Where possible, the agents reran the available materials and compared the results with the claims in the paper. That matters because I read the paper and I actually reproduced the result are two very different sentences. Out of those 168 oral papers, 92 had at least 5 claims the system could assess. Only 34 of those papers had more than 2 of the 5 claims reproduced. Raise the standard to more than 80% of claims, and you are down to 8 papers. 8. I need you to sit with that number for a second. Does it prove the other papers are fake? No. Reproduction can fail because code is missing, data are unavailable, environments are messy, or the checker itself gets something wrong. The SAI page itself separates papers with code, papers without code, and work that has not been started. But that is still part of the problem. If a scientific claim cannot be checked, rerun, or clearly traced, then what exactly are we doing? Prestige is not verification. Peer review is not a magic force field. And trust me, it worked on my machine is not a foundation for human knowledge. Then we get a second result pointing in the same direction. Researchers built a GPT-5-based paper correctness checker and used it on papers from major AI venues. Importantly, it was not judging whether a paper was exciting, original, or beautifully written. It focused on objective errors, formulas, derivatives, calculations, figures, and tables, things where there is a checkable right or wrong answer. For NERM IPS papers, the average went from 3.8 identified errors per paper in 2021 to 5.9 in 2025. That is a 55.3% increase in 4 years. And please do not glide past that because decimals make your brain sleepy. These are published papers. New research gets built on top of them. If the foundation contains a wrong equation, a mislabeled figure, or a broken calculation, every later paper that relies on it can carry that damage forward. This is how 1 tiny crack becomes a very expensive wall. Human experts reviewed 316 potential mistakes found by the checker and confirmed 263 of them. That works out to 83.2% precision. The system also proposed correct fixes for 75.8% of the identified mistakes. That is genuinely impressive. It is also not perfection. And this is where I need everybody, including the AI people, to calm down. The answer is not to fire every reviewer and let a chatbot decide which science is true. These tools can miss assumptions. They can flag correct work as wrong. They can invent a problem that does not exist. Other testing discussed in the research found that even strong models caught only a fraction of errors that human reviewers had already identified, while also producing false positives. So if an AI checker says, "I found a mistake," that is not a verdict. It is an alarm. A qualified human still has to walk into the room, smell for smoke, and find out whether anything is actually burning. That distinction is everything. Use AI to check arithmetic? Absolutely. Use it to compare a figure with the numbers in a table? Please do. Use it to rerun code, trace citations, and point an expert towards something suspicious? Yes, yes, and yes. But should AI make the final call on novelty, importance, or whether a paper deserves to exist? No. Those are human judgments, and the researchers behind the checker deliberately left them out. The best evidence for this balanced approach may be what scientists are already doing with these tools before publication. In a survey of 733 ICML 2026 submitters, 35% said Google's paper assistant tool caught errors in their own work before they submitted it. And 31% said the feedback pushed them to run new experiments. That is the version of this future I actually want. Not AI humiliating scientists, not scientists pretending AI is useless. A machine says, "Hey, this looks weird," and a human responds, "Okay, let me prove it." And weirdly, we have seen this relationship before. 10 years ago, AlphaGo played move 37 against Lee Sedok, a move so unlikely for a human that it was estimated at 1 in 10,000. Experts initially thought it looked wrong. It turned out to be brilliant. It forced people to see the game differently. But later in that same match, Lee played move 78, another 1 in 10,000 move. This time, the human found the move the machine could not handle. That is the whole story in 2 stones. AI can catch the error sitting in front of us for 75 years. It can process more papers than any exhausted review committee ever could. It can find patterns, contradictions, and possible fixes at a scale humans simply cannot match. And it can still be wrong. Humans can miss obvious mistakes, protect prestigious systems, and repeat bad information for generations. And humans can still find move 78. So no, I do not think the lesson is science is fake. I think the lesson is more uncomfortable. Science is human. Peer review is human. Databases are human. And humans make mistakes, then sometimes put those mistakes in a very official looking PDF. AI is now holding up a mirror to that system, and people are not going to enjoy what they see. Good. Because if the result is cleaner data, reproducible experiments, and fewer researchers wasting months building on something broken, then let it be uncomfortable. Just do not replace blind faith in institutions with blind faith in machines. That machines will keep giving us move 37. Our job is to verify it and keep looking for move 78. Don't forget to like and subscribe, and I'll see you in the next one.